The choice now for threading in our server comes down to making sure we put the threading in the right spot. Now, truthfully, we could put it in the wrong spot. It probably still would work as far as the testing goes. And so this comes down to just getting it right as far as planning goes. You could screw it up, make it not work anymore, and that's difficult, challenging, annoying, but a good thing because then you know you didn't do it right. But for us to get it right, we need to do it not just so it's working, but so it makes sense and it looks right in logical terms as we're going through here. All right, so we spent the time to refactor. We have our client manager, and all the stuff that we converse with the client is hidden from there. Now we need to add in threading. Now, we could make our client manager a runnable. That's a perfectly reasonable thing to do. And so, instead of having to introduce a bunch of additional complexity, we could try and make the converse with client a run method. That is also acceptable inside of here. The problem with that is if we do that, then we have to refactor even further and do additional things on that, and we might be making this less reusable even still. The idea of a client manager was to create a reusable component. So instead, we have a choice to make. We can make this runnable and have one option as running this guy as a thread, or we can create a separate class that makes this a runnable version of a client manager. And that's essentially what I want to do here, just to kind of show you that variation. I mean, a lot of this is high-level design, a lot of high-level planning. Much of this would never even be required on an application. I don't need to have a reusable component that sometimes runs with the thread and sometimes not. I just want to show you this type of thinking. This is the way that really experienced programmers start to construct code to be able to put things together in a way where they can essentially have all these reusable components they can pull off the shelf. So what I want to have is a, we'll call it a runnable client manager here. And so I'm going to get rid of some of this fluff up top. And the most important this thing needs to do is implements runnable here. Okay? Now, at this point, I need to have a run method. Hold down Alt, hit Insert, and I want to implement the run method. So I picked Implement Method. I select Run using my spacebar there, and then I have my runnable here. And now I'm officially a runnable. I need to implement this guy. So what do I want to do here? Well, I want to create a client manager. New client manager. And then I want to be able to run that client manager. Except for I need to do it in the oh no, I'm in the thread. Yeah, I'm sorry. I'm already in the thread. So at this point, I want to say converse with client. Now, where do I get the input stream and the output stream? Well, if you remember back to how we customized a thread before, I add those pieces as part of the constructor. I put those in and I add them over. Now, we have a choice to make here. We can make this to be super reusable and have an input stream, output stream be handed into here. Or we could also do it with the socket. We pass the socket in and pull it from the socket. Since this is a bridge class, it's cheap to write. There's only a handful of lines of code. You could do it either way. It really doesn't matter super much. Since we have a good feel for it already, we can go copy some of these things already. I think what we'll do is we'll keep the two different input streams and output streams. So I'll show you what I mean by that in a second. So private input stream, control space, it's in private output stream, control space, output stream out. Sorry, I'll clean those up a little bit. And I'm going to do Alt and Insert again. I'm going to insert a constructor this time. Hit Enter on that. Select my input and output stream. Use my space bar there. And I'm going to generate here. And so I have a constructor that gets in and out. And when I go start my thread, I can pass along the input stream and the output stream that I want to talk to. So just like that, there's my runnable. I implement my runnable interface, that's the requirements out of there, in order to have my run method. For my run method, all I'm doing is I'm saying, hey, the client manager is the person who really knows how to do the work. I'm going to punt the ball over to them, but I've now wrapped that in a thread. So this will run on its own. When I talk to a client, it has its own thread in order to do that work. This is actually a very common pattern to separate out the behavior from the threading. I have the basic behavior you can call, or I can call it as a thread. So I'm not locked into being a thread, but I can wrap it pretty easily as a thread. The biggest issue here is now notice I have an exception I have to deal with. So when I add in threading, I'm essentially treating this like its own little program. And I can no longer have the overall, hey, somebody else deal with this. Because remember, lines of code are sequential. The one happened after another after another. If a thread dies, the thread dies. It may or may not influence the rest of the program, depending on what you want to have happen. So I have to deal with any checked exceptions, anything like I/O stuff that's going to go on. So when I do Alt-Enter, I don't have the option to throw this because the run method cannot throw an exception. The threading mechanism says you have to handle this. We're not designed to handle this stuff. You have to handle this. There's actually two ways I can deal with this, but I still have to catch it. So I'm going to surround this with a try-catch block. All right. So there's two different exceptions. If by default, you can see it puts them separately. If I want to handle them differently, I can. Or what I'm going to choose to do here is I'm going to delete these in-between lines and just catch the exception to the class. If anything goes wrong, catch it. Now, what do I do in response to the exception? Well, there's two options. If this thread dying is not the worst thing ever, then I just log the exception. If this thread dying means my whole program can't function anymore, then I have to some way let the whole program know something went wrong. I can gracefully shut the program down. I can ungracefully shut the program down. The worst case scenario is I can actually rethrow a new exception that's a unchecked exception. It's like a runtime exception or something like that that would kill the whole program by default. It's a very heavy-handed way to do it. You should preferably design a way to do it. In our case, if something goes wrong with one client, probably logging is the best mechanism. So somebody asked for something, like one person calls in and the customer service agent has a stroke. I can't talk to the person. Well, they can call back, talk to somebody else. We have the phone recorded. Oh gosh, we better go give that person some medical attention. But the point being, in the dramatic example that was, it's not the worst thing ever. We don't have to shut down our business because we couldn't complete one phone call. That's essentially what we have going down here. So we're just going to basically log the exception. That's perfectly fine behavior for now. Now we have our runnable up and ready to go. If we go back to our main thread, not this one, not this one, a server right here. Instead of running the client manager directly, we don't want to do that anymore. What we want to do instead is we want to create a runnable client manager. All right, we can get rid of this client manager right here. All right, so for the runnable client manager, we need to pass in these two guys right here, the ones we conveniently did. This was I was saying I can copy these guys and paste it up here, and that makes my runnable client manager. The other great thing about creating a bridge object, an object that is a bridge between not having threads and the functionality and having threads and the functionality, is now I can't accidentally call the wrong behavior. So if I say cm.here, I do not have a method for converse with client. I only have a run method. And I probably am not going to think of, if I call the run method, then I know I'm probably doing the wrong thing. So this kind of sort of encourages me to create the thread object. Not guaranteed, but now I should have a thread object. T is equal to new thread. And for that thread, I want to pass in the client manager here, the runnable there. That is the client manager. And then t.start. So we just took a big convoluted long way to get to a pretty simple set of lines of code, but the point of that was to really emphasize the different things that are happening in our application. Our main application does just these handful of lines of code. I create a socket, and then forever, while equals true, forever, I'm going to get a new client. I'm going to create somebody to deal with that client. I'm going to create a thread for that person, say, hey, go deal with this client. Oops, sorry. I cannot do this line of code right here. This actually would break right here. You would catch that when we go off and run it. Because if I do that, basically I'm saying I hand you a phone, then I hang up your phone right away. So that's a bad thing. But we can deal with that. Let me actually show you, just out of curiosity. Run, stop. We just run this. And let's go through and run a client. We may or may not see it. Again, some of this stuff is really hard to detect in real-time systems. Unable to contact server. Yep, see the server died right there. So you can see the exception that came up because I closed the socket right here. So I need to take this line of code out and go from there. I'll tell you the reason why it's not necessarily a problem in a second. But let's do this one more time. Let's stop the server. Let's run the server. All right, now let's run the client. Make sure we're up and running still. Oh, there you go. Get names, get places. Get names, get places. By the way, we can do this at any point, but I can go run the server. I can run the client again. So I have 2 copies of the client out here. There's the one copy. Here's the other copy. Get names, get names, get places, get places, get names, get names, get places, get places. You wouldn't necessarily notice this behavior either way, but they are running each request within its own thread. All right, so back to this. The whole point of this was I create the server socket. I get a call on the server socket. I shuttle you off to have somebody else go deal with that, and then I immediately circle around to go look for the next call. This essentially is the operator. The person who answers the phone says, "Hello, welcome to so-and-so. How can I help you? Let me transfer you." "Hello, welcome to so-and-so. How can I help you? Let me transfer you." And that's what they do all day long. They're the receptionist. They're the operator. The point is that person then can at least be responsive immediately. Whether your phone call is going to take 30 seconds or 20 minutes, I'm giving you to the person who can dedicate their time and focus on that. And that's what threading is all about, letting you take as long as you want to there. So this big set of steps got us to the point where we could separate out that conversation and then easily and sensibly wrap this stuff up. We can see each step of it along the way. This guy deals with the threading. This guy deals with the conversation. Boom, there it goes. Now, the reason why the input and output stuff is not necessarily a problem, what we could do is when we get to the bottom of this right here, we could close the input stream, close the output stream, which is the same net effect of closing the socket, which, by the way, I'm going to move this over one so it's a little bit easier. The reason why this works is when the thread is finished, that thread will be recycled, and then that socket will be recycled, and then it'll close out automatically. On the recycling of the socket, there's an actual method that goes off and closes the socket. It should be good. It's always good to explicitly close it because then you close it sooner, because that thread might not be recycled for a long time in a computer sense, which keeps that socket open potentially. But if the client's giving up, then it kind of helps us a little bit. We can maybe get away with it. It's certainly good enough for what we have going on. It's good enough for what we have going here. But it actually makes a good argument why you might want to pass a socket into this right here. As you could say, converse with client and then close the socket afterwards. All right, so that is enough, hopefully, for you to be able to get your week 2 work done. If you have any questions, as always, bring them to the chat, email them up, and we will see you next weekend.